Hello everybody, welcome back to our Math A&A Friday. I'm excited we go through Unit 1's SL. Now we are on AHL. AHL is about some extension of the something that previously we have learned. So some of them, when you heard of it, you find it very familiar, but there is some more advanced thing that you have to understand. So now let's get started. What about binomial theorem? So it is additional higher level. If you're an SL student, you can visit our website to look at the biology, chemistry, and economic stuff. And for 1.7 is about just like some probability stuff, like a counting principle. There is an extra thing called counting principle. Okay? There are different ways of doing counting. Okay? When you look at the question, be careful of the wordings in the question. For example, addition and multiplication rules. So we use the addition rules or multiplication rules. Look at the question clearly, okay? If we have n groups of choices, okay? Each has a lot of choices, okay? And if they talk about, okay, total number of choices of choosing one from all the groups, okay? And then what is the number of choices? Just add all the choices together. But you said that total number of choices for choosing one choice from each group. So each group can have n1, n2, n3 ways to do so, right? So multiplying all together will be the number of ways of choices, okay? So it is the addition rules and this is multiplication rules, okay? So try to understand which to use in different scenario. Okay, bring your paper now is a practice time, okay? Look at this situation, okay? Example 1a and b. So we use addition rules or multiplication rules. Okay, welcome back. Look at here. A student randomly chosen from the whole school. Whole school. So low problem. Addition rules. Okay. 40 times 35. Randomly chosen from each class of the school. Oh no, each class. So 40. Each one have 35 choices. So the total number of choices is 35 to the power 40. So it is infinite. You can't use a calculator to find it. Infinite way to join to form this group, okay? Okay, permutation is that something new that we want to introduce. We don't have it in SL. So first of all, remember what is a factorial way. Number of ways of lining up and things is n factorial. And in this AHL, we want to understand what is the application of n factorial, permutation, and combination more. Okay. So first of all, factorial and permutation. Factorial is n factorial is 1 times 2 times 3 times n. Permutation is very similar to combination, but just n factorial over n minus r factorial. So the r factorial is missing here. There are different ways to write down. In IB, I found out in this year's this NPR way, right hand side is more popular. So n and r must be integer. The upper one must be larger than the lower one. Okay, and some special cases 0 factorial is 1 is the definition. Okay? 1 factorial 1 times itself is 1. Okay? MP0, what is this? Okay, look at here. MP0 n factorial over n minus 0 factorial. Oh, 1. How about MP1 n minus 1 factorial? Oh, n. So you find it's quite funny, right? Look at it. Different special cases of NPR and factorial. Special relationship, this is must be true. Okay? So NPR must be larger than or equal to 1 because n is larger than or equal to 1. Okay? If x is larger than y, then x factorial is larger than y factorial. So npx is larger than npy because of minus divide. Double US. Okay, try to work on it. Okay. See, remember what is the definition of permutation? Welcome back. Okay, see, we got it. Yeah, n plus 3 factorial over n plus 3 minus n factorial. So n plus 3 factorial over 3 factorial. So n plus 3 factorial over 6. Sometimes they want you to expand the 3 factorial. Of course, in the paper 2 or paper 3, you can use a calculator to help you. Okay. Permutation in calculator. Then we want to investigate deeper in AHL. why we leave factorial, why leave permutation and combination? It is a way of counting. For the factorial, it means that you have n thing and choose n thing from n thing. Choose all the object. All the object is being chosen when we use the number of ways we use a factorial. If only some is being chosen, and chosen to form a sequence. Okay, so the times of choosing is important. There is a permutation. So for example, consider we arrange n objects without repetition. Okay. So if we just arrange them without repetition, arrange them all, then this is n factorial way to do so. Very big number. For example, n men a pair of with n women. Okay. Form a pair. So number of ways to pair them up is n factorial. Okay. So number of ways to choose R object R is smaller than n from n distinct objects. Okay. And then form a sequence of choices. It's important. And then it would be just n times n minus 1 times n minus r plus 1y. And this thing exactly is the permutation. This is the reason why we define permutation in this way. Because choosing r objects from n objects with the sequence important is exactly NPR. We name it NPR, not NCR. Okay. So for example, my bed has n different balls. Okay, our balls are drawn from them one by one without putting back. Okay, no repetition. Okay, and then the number of sequence of ball drawing is NPR. Got it? Remember, get all the object n factorial. Okay. Get some of the object, but the sequence is important. Is NPR. Okay. I'll try to work on it. Get difference. Yeah. IBDP always give you some surprise. Pause and work on it. Welcome back. Do you got it? Actually, this thing is just to separate NPR, NCR, NPR. Look at it. A factorial. To separate factorial. Okay. 7 girls, 6 boys, sit all 2 boys or 2 girls and sit together. It means that the girl has to sit at this place, right? 7 girls, 7 place. Okay. 7 factorial. 6 boys, 6 place between them. So 6 factorial. Add them, multiply them together. Wow, big number. 3,628,800. And then combination, we remember we learned it already, but we recap here a little bit because we are learning factorial, permutation, combination together. They have different definition and different application in accounting in probability. And see how all of you remember n factorial over n minus r factorial, r factorial. So the special term, we got it already. We learned it before. And now we can, by the definition, okay, compare with NPR, NCR has one more 1 over n, 1 over r factorial. It should be r, sorry, typo. It should be r factorial, okay, sorry. And we know that because this divided by 1 over r factorial more, so the NCR must be smaller. But for the NCX and NCY, there's no definite relationship. We can't say x is larger than y, so NCX is larger than NCY. No. NPR we can. NPR, because we have 2 terms in the denominator. We don't know the combination which one will be back here. Okay. Working time. Okay, bring out your paper, work on it. Okay, you can use your help. I'm okay with it. Welcome back. You got the answer? Yes. Just follow the definition of NCR. Okay? NCN minus 2, and you find it now is a quadratic equation, solvable, integer value. Remember, n must be integer. If we got n is 10.5, then remember, drop it. Check your results. Okay. It must be an integer, and the negative integer is rejected. Combination in counting, how do we use a combination in counting? We didn't talk about it in Excel. Combination in counting is we choose R object from N object, and the sequence of choosing is not important, then combination. If the sequence of choosing is important, then permutation. If all the object is chosen, factorial. So there's 3 stages: factorial, permutation, and then combination, from large to small. Okay. For n distinct objects, our objects are chosen at the same time. Okay. Without counting the sequence of the choices, the number of combinations is NCR. Okay. If the sequence is important, NPR. If R equals n, then n factorial. I'll look at this thing. It's a little bit complicated, but think about it. You can do it. Okay. Come back 2 cards at 12A and 12B. What do you do to each of them? Choose 2 people from 12A, 3 people from 12B, right? Just choose people from them. So Sequence important? No. So use NCR or MPR? Yes, NCR. So the 30 choose 2, 30 choose 3, right? Right? You got it? Well done. And then we can even extend the binomial theorem to factorial and negative number. Yeah, it is some proposition you do it in AHL topic 5 calculus, and then but it is not so easy. It is a Maclaurin series. Okay, it's an expansion. Okay. And in this part, because 1.8 is partial fraction, you just have one thing to talk about, so I add it here too. But 1.8 we talk about partial fraction. It is AHL skill, okay? And this skill is important when we do integration later, okay? What I mean is that you have two fractals in the denominator. Can you separate them one by one? The fraction only have x minus 1, the second fraction only has x minus b. Yes, we can do it. Okay? And then we can look at it to do the reverse process, and then the same coefficient. So the coefficient of x is 0, the coefficient of constant term is negative, is 1, and then flip it, change it, and then we got all the thing. You find it a very sophisticated theory, okay? It's just a show off, and I use a variable to derive one with you, okay? With the number, you can do it too, okay? In the exam, they'll give you the number, what is A, what is B, 3, 4, or 7, what is capital A, capital B, they'll give you too, okay? Okay, bring your paper, try to work on it. Linearize. Linearize means not quadratic, make it x minus 3 for one fraction and x minus 4 for another fraction, okay? Try to work on it. Welcome back, okay? So assume they are linear, and then by engineering, group them, and then find it out, okay, which is which, and then you have two equations. Solving the two equations, you got the two unknown a, b are the same. They are negative 2. Excellent. Then negative 2. A minus 2. X minus 2. X minus 2 here. You get it? Well done. So thanks for going through it with me. Okay, we are entering AHL. Okay, if you haven't choose SL or HL, yes, then you can watch some more this video to see whether it is too hard for you or it is too funny for you. Some students found SL is too easy. They want to study AHL as a challenge. As a reason for university entrance is also okay. Some subject require HL for mathematics, even A&A. Okay. So see you for next week for another Math A&A Friday. See you. Bye.